So the next one is a keynote, From Tools to Partners, the Rise of Agentic AI. And our presenter is Martin Flechl, Head of Generative Artificial Intelligence at Dynatrace. This keynote introduces the foundational concepts of Agentic AI, explores its current applications in business and research, and highlights emerging trends shaping its future, such as agent-to-agent protocols and MCP servers. We will gain insights into how Agentic AI is poised to revolutionize industries, from dynamic problem solving to personalized user interactions. Martin, the floor is yours.
Thank you very much. Thank you. Thanks for being here today. This plot here shows the number of tokens processed in 1 month by Google. You can see in last month, in September, it was 1.3 quadrillion, quite a new unit actually that we've barely been using in the past. It's a 1 with 15 zeros. It's hard to even imagine that, also for me. If we put that in context, all books ever published are about 20 trillion tokens, so it's down here. So every month, Google processes 2 orders of magnitude more tokens than all books ever published. Quite remarkable, I think. But what's even more remarkable, this number is increasing very rapidly. It has increased by a factor of 100 in just a year. And if anything, the increase is even more increasing, right? It's almost like an exponential growth at the moment. And a lot of that is due to agentic use cases, in particular due to coding assistance. At the same time, token prices are going down. If you look at a fairly smart model, like on this pink model, 1 year ago, 1 million tokens would have cost you about $30. Now it's 8 cents. So you can get 12 millions for $1. It's really amazing. Still at the same time, enterprise adoption of AI is increasing. That's not really so surprising. This plot is actually quite old, from the first quarter of this year. But what's most remarkable, I think, again, we can see something has been happening at the beginning of the year. There's some inflection. It's increasing ever more than before. So the number is 42%. That's not so important. By now, I'm sure it's much higher and probably getting very close to 100%. But it's really not just a lot is happening, but whatever is happening, it's even increasing ever more so. One of the reasons for that is coding. This is, I would say, the first business use case that really brings revenue to LLM providers and LLM adopters. And it's been, again, a very rapid journey. 1 year ago, there was essentially one tool on the market, GitHub Copilot. Now, 1 year later, we have a lot of competition. This year lists only a few of them, like Windsurf, Cursor, the new vibe coding platforms, all with very significant revenue. Still, the revenue is less than the costs, but that's probably just a question of time. But for the first time, for business use cases, very significant revenue. These numbers are already outdated because they're a couple of months old. We are now talking already about a market of around 10 billion or so in ARR. One of the reasons for that is that models become ever more powerful. This plot here shows on the y-axis how long it would take a human to complete a certain task. On the y-axis is, of course, time. You can see at the beginning, GPT-3, 3.5, they could handle tasks that would take a human maybe a few seconds or a minute or so. Now we are already at a couple of hours. But again, the remarkable thing is not where we are now, but how quickly things are evolving. You can see it looks exponential, and it is exponential. If you do it on a log plot, you can nicely fit a straight line to it. And what you can see is that this time scale actually doubles around every 6 to 7 months. So if you want every year, models can handle tasks that take 4 times longer. If it continues like that, there's of course no guarantees, but at the moment it really looks like that. Then in just a few years, AI agents will be able to handle tasks that take a human being about a month or so. And that will change a lot because we will not have one AI agent, but an arbitrary number of AI agents, right? Maybe billions of AI agents all working parallel, doing in maybe a few minutes what humans have before been doing in a couple of months. And yeah, I think it's hard even to imagine what this world will look like, but we are not far away. Quick question to the audience. In your organization, your company, your institute, how many are already using AI agents or have even deployed AI agents? You can see a few hands up. Now a few more. Yeah, if we look at this recent survey from KPMG, again, something remarkable happened at the beginning of this year. In the first quarter of 2025, around 11% of companies said that they have deployed AI agent, and then within just 1 quarter, this number tripled to 33%. It cannot continue tripling because then we would be beyond 100%, right? But it still keeps increasing. Last quarter, 42%. Probably it's now more than half of the companies. So if you think AI agents are the future, you may be right, but very certainly AI agents are already the present, actually. Yeah, so thanks for bearing with me so far. My name is Martin Flechl. As I've been introduced, I work for a company called Dynatrace. I will not use this to shamelessly promote the company, even though it's cool and you should totally check it out on our website. I want to mention one thing, though. If you would like to work with AI for the best employer in Austria, and that's not what I'm saying, we have that certified from various companies. If you want to work with the best employer with AI, have a look at our career portal. We have lots of roles out there, developers, researchers, product managers, and so on. Check it out. All right, let's get to the basics. What is an AI agent, actually? A lot of people are talking about it. Some people have a vague idea what it is. Some people maybe a more concrete idea, but there's also, of course, lots of different definitions floating out there depending on who you ask. If you ask marketing, essentially everything today is an AI agent, right? If it even smells a bit like an AI agent, you've probably seen some of these memes, and they're a bit of an exaggeration. I like that one. I changed all our loading states to thinking. Now we are an agentic AI startup. It's a bit of an exaggeration, but not by huge amounts, I would say. Yeah, everything that is kind of an automation nowadays is an AI agent. That's not the definition I want to work with here today. If you ask scientists what is an AI agent, you will get a very complex answer, not unexpectedly. I've seen this matrix here. I will not go into details here. What's interesting here, though, is these 2 dimensions of definitions for AI agents. One of them is, well, agency or autonomy. So to what degree are the agents able to choose their own actions, what to do? And if the answer is none, then it's simply a workflow. It's often sold as an agent, but that's not an agent. There needs to be some agency, otherwise it's not an agent. At least that's my opinion. Then some people have different ideas how much freedom, how much autonomy this system should have to be called an agent, but that's then a question of days. But definitely there should be some degree, right? The other, which I think is less important at the moment, is the effect on the world. Some people say it's only an agent. Okay, this is not working anymore. Some people claim it's only an agent if it's able to interact with the world, so at least read from the world, have sensors, search the web. The screen is not working anymore. If you can fix that, would be great. Some people say it should even be able to write on the world, so either to a database or take actions in the world as like a physical manifestation, as a robot. Yeah, it's a question of how you see it, how you define it. I think for the rest of the discussion, this is not so important. What's more important is this autonomy aspect. So going back to that autonomy, what do we actually mean with workflows? The simplest cases of workflows is shown here on this plot. It would be just chaining LLM calls, for example. So input, one LLM processes his output, goes to the next LLM. This is not an agent because it's just a workflow. There is no choice of actions at all here, and definitely not by the LLM. You can have other cases which are more complex in parallel. You can, yeah, if it's that, it's not an AI agent. If there's one thing you take away from this. You can have more complex workflows which look a lot like agents, but which are not really agents yet. So here, the LLM already chooses a path. It doesn't really have freedom to choose an action, but at least it can choose between predefined paths. If this happens, then do that. If that happens, then do that. So it's more like a big if-then-else tree or something like that. What an agent looks like in the very simplest case, what it needs to have is shown here on the right. It needs to be able to call tools, and that means it has some freedom to choose actions, because a tool call is not just choice 1, 2, or 3, but you can call a given tools in an infinite number of ways typically. Imagine one of the tools being web search. You can call that tool in, it's not limited the ways in which you can call that. Same if you have a code interpreter as tool, for example. What's also important is this feedback loop here. The LLM calls the tool, but also consumes the feedback and then decides how to continue. Call the tool again, call another tool, or there's enough information and answer the user. All right, now let's come to, I think, the most practical way of defining an agent, just looking at how in practice agents look today. What you have always at the center is, of course, an LLM. Then there is if you look at how it's used, the user queries that LLM. The LLM has access to storage that serves at least two purposes. One is a knowledge base, think Wikipedia or whatever, some database. The other is memory, remembering past conversation, but also previous turns from this conversation. So that gives the agent some state. It's not like just an LLM chatbot where every turn the conversation starts anew. Then any decent agent has access to tools. We already had that, very generic tools like web search, can also be something very specific like sending emails. An agent can also have LLMs as tools or even other agents as tools. That's also possible. And then typically there's some planning and reasoning capabilities. So if there's a complex task, then the LLM can break it down into smaller tasks and then process each of them in turn, orchestrate the resolution of these tasks in the end. Okay, so far what we've talked about are just single agents. What has been discussed a lot also in recent months are multi-agents, so more than one agent involved. There are different patterns. I at least want to briefly also mention that in the context here. The so-called network pattern. So here you have several agents which are equals, more or less equally communicating with each other. The most common pattern is the supervisor pattern, where you have one agent that directs other agents. So think of one powerful, smart orchestrator, and then lots of agents for very specific tasks. And the orchestrator chooses which of them to call when and consumes the output. Hierarchical, this is just additional layers. This is more or less what you would think how a corporation also works. And then there's the custom model, which is in practice how most corporations, organizations work, right? The more chaotic. Some people talk to each other, some do not. Some have like a supervisory role, some are equals. Everything is more or less possible. All right, lastly, just one point, because that's discussed a lot. I don't think the distinction is super important, but what is an AI agent? What is agentic AI? I think a practical way to approach this, an AI agent is something where a human sets goals and then the AI executes, while agentic AI means humans just set values or maybe some very broad goals, and then the agent chooses their own very specific goal. Let's look at some examples. For an AI agent, it would be, for example, a self-driving car. Human says, I want to get to point X, and then agent figures out how to get there and then executes. So clear goal and then execution. Coding assistant is the same. Human says, I want code that does this and that, and then LLM agent plans and executes. Agentic AI would be more or less every agent you've ever seen in sci-fi, so very much human-like agency, setting to some degree, at least within some framework, within some guardrails, their own goals. So this is something that I would say does not really exist, even though we are getting closer to also agentic AI. All right, so that's just to set the stage. Now let's have a look at some of current trends in agentic AI. As it turns out, many of them revolve around three-letter acronyms. You probably know a few of them. Anyone with any three-letter acronyms? MCP, I expected to hear that. Anything else? A to A, yes, I also expected that. Great to hear that. There's a few more, even in the last couple of weeks. ACP, AB2, we'll get to that quickly. Seems to be very sexy these days, agentic three-letter acronyms. Let's nonetheless start with agentic frameworks. What is an agentic framework? Essentially, you need it. If you want to build an agentic system, you need a framework. You can also produce that framework yourself. It's not even that much of a hassle because typically, I mean, the basics are quite simple, but still most people choose an existing framework that makes it much easier to get started, obviously. Currently, in the past, and I think still today, the most popular frameworks, I think, are these, LangChain, LangGraph. They are very much connected, and GRU AI, but there's really dozens of them on the market. but even more remarkable, essentially dozens appearing newly every month. And just in the last month, we've had from Microsoft the Agent Framework 2 weeks ago, from AWS Strength Agent SDK in the summer, but now Agent Core, which is not really an agent framework, but very much related. It's not public yet, but there's, I think, a private preview. And from Google, Enterprise Agents, just from last week. So within just the last couple of weeks, all of the big cloud providers, all of the hyperscalers have provided their own frameworks, or again, provided new frameworks. I think that's a very interesting trend. I think what it points to is that agent implementation is a thing that has been dealt with a lot in the past, and that is not always easy, but that's, you can, on your own laptop, you can set up some agentic system in 1 or 2 hours. It's possible, I've done it, it works. Deploying agent, it's a much more tricky thing. You have lots of different components, and I'm speaking of a production environment, right? You have lots of different components that you need to deploy. They need to be able to talk to each other in a secure manner, authorization, privacy. It's a lot of stuff to consider. That's really complex. It's a lot more work to deploy this stuff than to implement it most of the time. And if hyperscalers directly offer this framework, that's at least the promise is that a lot of this burden is reduced. Okay, but that's not the only new thing. Also, Claude released Agents SDK 2 weeks ago, and last week, OpenAI released Agent Kit. So you have all the big hyperscalers, all the big model providers, all of them with new frameworks just in the last month, which tells you how much is happening, how much buzz there is in this scene at the moment. So let's get to these 3-letter acronyms. MCP, I think all of you have heard of it. Probably a lot of you have used it. I hope many of you also know what it is. If not, I'll at least briefly get into it. An MCP setup consists of 3 components. One is the MCP host. This is the application that you're running. Could be an actual app, like Claude Desktop. Could be in the browser, ChatGPT. Could be in an IDE, a programming environment. This MCP host has built in an MCP client. So that's still part of the same application, which talks to an MCP server. There are 2 versions. The MCP server can be local, running on your laptop. That's useful, for example, to provide access to your file system. It could also be running remote somewhere on the internet, like, I don't know, Slack, Dynatrace, or a GitHub MCP server. And behind that MCP server are, of course, then some resources that can be almost anything, databases, whole GitHub, Dynatrace, whatever you would like to connect as a tool. So you have these 3 components: MCP host, MCP client, MCP server. What does that mean in practice? So in the past, if you wanted to connect your LLM to tools, then you had one API for each of these tools, typically each of them different. So you had to write some custom connections to all of them and maintain them, of course, change them in the future, which, if it's 3 of them, like here, may still work. But if you want to have that flexible and extend it, it's a lot of work just managing that. And today, with MCP, you can just use one unique API, and that then connects to all the other services. So MCP, in a way, is an API for APIs, which doesn't sound super sexy, but is actually very useful. If you look at the MCP ecosystem, it's huge already. So if you look, I just checked out one of these listings of MCP servers. It listed almost 17,000 MCP servers. Are all of them being used? Certainly not. I think a large number of those are not used at all. Many are used maybe just by a handful of people, but a few of them really have gained traction and are very heavily used. Some people claim that MCP is the only piece of tech that has more builders than users. It's probably not true, but also not so far from the truth. But the point is still, there is at least a few dozen, maybe a few hundred MCP servers that are actually super useful and that are used a lot. Why is MCP important? I already pointed it out. If you want to connect your number of LLMs with another number of tools, you need to have the product of these numbers in connections, which is, very hard to maintain and very hard, almost impossible to really make extensible to shift to new tools when they appear. With MCP, it is just one if you do it right. MCP very certainly has its weaknesses, like around security, for example, authorization, and so on. There are lots of things that are not perfect. Very likely there will be improvements in the future, but even if not, at least in my opinion, it's better to have a bad standard than to have no standard at all. So it really enabled a lot of things that were not possible before. Okay, so much about MCP. Now the next three-letter acronym, Agent to Agent, A2A, introduced by Google initially, now part of handled by the Linux Foundation, so it's an open source standard. Let's first relate it to MCP. I've shown you before what MCP does. It enables AI models to interact with tools, while A2A enables agents to interact with other agents. Now that sounds like it's something very different. It's actually not so different because agents are models with something around them, and tools, well, agent can also be tools in some contexts. So there's actually some overlaps. There are some cases which both of them could handle and compete. That's not what happens in practice. In practice, they live quite happily next to each other, even though one should say MCP has gained a lot of traction. A2A, it's still, I think, adoption. Yeah, we will have to see in the future how it turns out, but it's not yet clear whether this will really take off. How they can live together is, for example, like that. You have one agent that serves as MCP host, and via the built-in client then consumes tools from an MCP server, and at the same time communicates with other agents via A2A. And these agents, it's not necessary, but they can even share the same tools via accessing the same MCP server. So yeah, very happy coexistence. How does this protocol relate to agent frameworks? So within agent frameworks, you can also have multi-agent systems, right? But then they all live in that same ecosystem, for example, LangGraph or GrooveAI or Microsoft agents, and they are all fully under your control. While with the A2A protocol, what you can do is you can connect agents from different ecosystems, from LangGraph agents with my LangGraph agents with your GrooveAI agents, for example, and there are some security boundaries. So if my agent interacts with your agent, I can make sure that it doesn't spill all the secrets, all the stuff that I don't want you to know. So again, they can live happily together. They fulfill very different purposes. You can have one agent living in one framework, another agent living in another framework, and then both of them talking together via A2A, and at the same time, MCP, another three-letter acronym again for consuming tools. Yeah, looks very nice and peaceful. Let's have a closer look at all living together, coexisting. Let's have a look now how it actually works, at least in a nutshell, what it actually involves, this A2A protocol. There are again 3 steps. First step is the discovery step. So a user, you, uses a client agent, for example, your personal assistant, that fetches agent cards from the remote agent or agents, a hotel agent or an airline agent. These agent cards, they describe what this agent is actually doing, how to access it, how to authorize, how to communicate with it. In a second step, once this information is there, comes the authentication. So the client agent sends credentials, and if everything is fine, gets authorization from this remote agent. And then in the third step, the interesting part, of course, they communicate. Client agent sends a task to the remote agent. If necessary, the remote agent requests more info. Then in the background works on the task that was given. If the task is long running, it can give async updates to the client agent. But in any case, at the end, it will give a final response. And if that's optional, some artifact, for example, an image, Excel table, whatever the desired result of the task is. Okay, so why is it important? Why is agent-to-agent relevant? Probably today it's not super relevant yet, to be honest. Now what we mostly have is isolated agents like coding assistants. At least one possible future is that agents from different entities cooperate. Today that only happens to a limited degree, but I mean a lot of people imagine, I mean at least, we don't talk to each other anymore. My agent talks to your agent, but also my coding agent might talk to the GitHub agent, which talks to the Dynatrace agent. And then all of them together negotiate with the AWS agent for some nice prices on EC2 instances, and then come together and deploy my app there, and everything runs nicely and everyone is happy. I don't know if that's going to be the future, but at least it's a likely version of the future. And how does agent-to-agent help there? What it mostly provides is authentication, some standards of how these agents communicate with each other, and maybe most importantly, security access boundaries, because if the agents talk to each other, there are some things that I want them to exchange in terms of information, but some things that should stay private. All right, so I promised more three-letter acronyms. Those are very recent, ACB and AB2. So ACB is the Agentic Commerce Protocol from OpenAI, which was released last week or 2 weeks ago from OpenAI. The purpose here is to enable purchases in the chat window directly from ChatGPT. So you can now ask ChatGPT for recommendations about, I don't know, some China in this case, it seems like, and then directly buy it in the chat window without ever leaving it. The Google protocol, Agent Payments Protocol, has a similar purpose. It's more open, so everyone can implement it. It's not limited to ChatGPT, but fulfills also a similar purpose. It's also just a couple of weeks old. Yeah, so what happens is you can share your credentials and then initiate a checkout and receive confirmation directly. And all of that, at least the claim is in a secure way without exposing any payment data. This is related very much, I think, to a different aspect that was revealed at the same time. You've probably seen it, these apps in ChatGPT. So you can now, whoever is collaborating with ChatGPT, whichever apps there are, you can directly call them from the chat window. In this example, you can ask Spotify to start playing your songs. This is, I think, all of this ties together in kind of a wet dream from OpenAI that ChatGPT serves as an operating system that you can do everything you want on your computer without ever leaving the chat window. Not sure if that's the future I want, and definitely it's not the future that everyone else than OpenAI wants, I think, because they want people to still be using their apps also directly. But yeah, it's at least one direction we might be steering into. All right, I already briefly mentioned it. Agentic coding assistants are probably at the moment the most important use case in terms of business and revenue. What this plot here shows, it's already a bit old. LLMs themselves can also produce code. And you can see here GPT 3.5, GPT 4, relatively old models for some benchmark, and both of them solve a decent amount of cases. These are these green dots here to the left. But if you then wrap something around it, some agentic capabilities like tool use and reflection and so on, then you can essentially solve this benchmark. You can solve almost 100% of the cases. And what's remarkable, you can even do that with this much weaker GPT 3.5 model. So with the right tooling around it, even weak language models can become very powerful in coding. That's why the agentic part here is so important. Agentic coding in terms of adoption has become the leading enterprise use case. So in this survey, almost 80% of all companies said that they are using coding assistants. And I mean, probably the number is now very close to 100%. At some point, I think it will almost certainly be 100%. The runner-ups, content generation and documentation, not so surprising. So this is in terms of adoption, but even more important in terms of revenue, it's really the prime business use case now, coding assistants. This compares revenue that OpenAI and Anthropic are getting. You can see to the left the consumer use cases, and here OpenAI is leading with a huge margin. To the right, the last two are essentially at least coding use cases, and you can see here Anthropic has already overtaken OpenAI, which is of course very neat for them because enterprise use cases is where also in the future there's a lot more money in it. I mean, from consumers, I don't know if you can ask even more than $200 a month for a subscription anymore, but for coding and enterprises, for sure, there's still a lot more a lot more money in the market. So we are already now approaching like a 10 billion market, but that's only going to increase in the future. I think one interesting thing is to look at how startups deal with AI. It's a bit different than the big enterprises. So this is top spend on AI that they have. The leaders are OpenAI and Anthropic. That's not very surprising, and it's not clear which products from these two companies they are consuming. But already on third place is Replit. Replit, probably have heard of it, is the leading vibe coding platform. You can also see the second big platform on this list, Lovable. So I think that tells you something, at least how startups work today. It's getting more into really this vibe coding space, not just some assistant in coding that helps you complete your code, but the assistants writing the whole code for you. This could mean that startups simply have to do that. They have to move fast, otherwise they don't even stand a chance to compete anymore. It could also mean that in the future that will also penetrate more and more also into the bigger companies, and that more and more code will really be produced that way. I think the jury is still out on that. So to summarize that, why are coding assistants? Why is that a very important topic? Coding is, I haven't said it yet, it's easy. Not coding itself perhaps, but training for coding, and that's also a bit of an exaggeration. But what makes it relatively easy is that you can generate training examples infinitely, because we can do it synthetically, but we can also verify the outputs, whether the outputs are correct very easily, because it's code. You can check if it compiles, you can check test cases, you can check if the output is what you expect. So getting training material is very easy. This is what's limiting most other use cases, LLM use cases, that there's simply a finite, I mean, you can only train on one internet, you cannot train on 10 internets, right? Then coding is super powerful. If people dream about AGI or ASI, there's always coding involved, because you need systems that self-improve, and that can only work via coding. So if you believe in any of that, then coding is the prime thing to focus on, and that's what all the big companies in Silicon Valley, I think, what their bet is on. And well, maybe profitable is the wrong word at this point in time, but at least it produces already significant revenue. So today, I think the usage is in enterprises. A lot of companies use it in production already, but only for like dev completion. So they start writing a function and then it completes. As I shown before, startups are really using it to produce essentially their whole code base. That's happening more and more, and particular driven again from US companies, but all over the world. This is really taking over, and it's very rapidly in the last 2 or 3 months. A lot has changed here, I think. Question is, how will it continue? At least for prototyping, I think it's also gaining traction in the bigger enterprises. So just to define it, vibe coding, what I understand here is that a human asks the coding assistant to produce a given piece of code that fulfills a purpose, and then doesn't even look at the code anymore. Sees the output, maybe refines it, asks, can I have that in blue instead of red, but never really looks at the code anymore. And the question is, what will the future look like? I don't know. We will see about that. Will that entirely take over? Will humans stop actually producing code directly? Yeah, we will see. But a lot is happening just these last couple of months. All right. Now going more into the business and public media direction. What are some of the hot topics that have been discussed recently? You've probably seen this study from MIT, where the claim is that 95% of all Gen AI pilots fail, and the implication that many people took away is AI is simply not working. And this is not true. There's a lot of problems with this study. I will not go so much into it. There was a very small sample size, and how they evaluated this number is also, you can criticize a lot of it. So I think no one should take this 95% very seriously, but a lot of pilots, a lot of stuff does fail. That's still correct. But what's interesting about this study is the major takeaway. What are the reasons for failure? And most of them are actually organizational, at least according to this study. So if you go here from bottom to top, unwillingness to adopt new tools, lack of executive sponsorship, challenging change management. So all of them organizational. That ties very nicely to a slightly older study, misalignment between leadership and frontline. I think that one was very interesting. Let's just look at this last question here. How many in the company believe that the company has a high level of AI literacy? If you ask the employees, it's 1 out of 3, 33%. If you ask the executives, it's 2 out of 3, double as many, 64%. So all the executives think we are a very sexy AI company. All the employees are more like, nah. Okay. So, are AI agents going to take our jobs? I mean, in some cases it's already happening, but on a large scale. Just a couple of points first. AI automates knowledge work, and in that sense it's very different to anything we've seen before. The plot to the left, what it shows, exposure to AI, so what fraction of tasks could AI potentially do in the near future, and on the y-axis, the wage, so the income. And you can see the higher the income, the more you could be replaced by AI. That's at least the finding of this study. And as I said, this is very unlike everything we've seen before. Not like the Industrial Revolution, not like the Digital Revolution. It was always more the blue-collar workers, the stuff that can be easily automated and done by machines. For that reason, I think anyone who predicts anything based on historic examples is just wrong. All these analogies don't work because we are at a really very unique moment in history. It doesn't mean that their conclusions are wrong. They may or may not be wrong, but their argument, I think, is wrong. We don't really know what's going to happen. So far, what we've seen today, also in this same MIT study, is that the layoffs due to Gen AI are not that huge yet, and most of them are in industries where already a lot of people have been let go due to automation, due to AI, and also among CEOs there is no consensus. There's some claim layoffs ahead in the future, some do not. So I think at the moment there is no clear takeaway here. A lot of it is still in the open, but at the same time, AI is not getting less powerful in completing human tasks in the future for sure. And one other thing is for sure, and that has already happened, a shift in skills that matter. Even now talking about work. A study is very interesting. You can check out the link. I don't have time to explain it in detail, in particular how they did all these metrics, but I can give you the main conclusions. Tasks that become less important in terms of earning salaries, getting jobs. Most of them not very surprising, analyzing data, documenting, administrative activities. The fourth one may be a bit surprising, establishing and maintaining relationships, maybe because now people think one-person teams can do what 10-person teams did before. At the same time, skills that get more important, organizing, planning, training others, assisting others, monitoring resources. So all of them have to do with supervision in some sense, right? Supervision now or training, helping now humans, in the future maybe your AI co-workers. Yeah, so I think the current situation is jobs consist of many tasks, that's a fact. If we look at jobs, for example, here customer service, we can see some tasks can be automated easily, like answering text chats. Some are more difficult, like handling complaints. And what happens right now is that tasks get replaced, not whole jobs. So humans shift, they focus then more on the complaints, less on the text chats. Of course, it also means overall probably you need fewer people, so yeah, workforce decreases, but it's not like there are massive layoffs. That's the situation today. What the situation will be like tomorrow, of course, I don't know, it may well change. If AI ever gets powerful enough to replace humans as a whole and not just some tasks of humans, then of course we will live in a slightly different world. Okay, I'm getting to the last part, just a few more slides. Thanks for bearing with me so far. So trends for the next year, and I think already most of them have already started now. I go a bit more quickly, but happy to discuss also offline and over coffee with you guys. Memory is an important aspect. Human memory is very complex, lots of different aspects. The sensory memory, short-term memory, long-term memory. Long-term memory consists of very different parts, actually. Currently, LLMs, they only have short-term context memory. Agents, if they are stateful, they have also long-term memory because they can load off information in a database, store previous conversations, for example. But it's still not really at a human level. Nonetheless, it's already a very important research area, and for various reasons. One of them, from a business perspective, it provides some kind of moat. If you use ChatGPT a lot, if ChatGPT knows everything about you and your business, then if you ask questions, you are very likely to get also answers that you expect. You don't have to explain everything again from scratch. Now, if a new, more powerful model comes up, you might be tempted to switch to Anthropic. But given that ChatGPT already knows everything about it, you might have less incentive to do so, because then you need to teach, I don't know, Claude Sonnet everything that you've taught ChatGPT over the last half month. So that's very much related to personalization. Another important aspect, continual learning. Models get trained, then they get deployed, and then they don't learn anymore. It's very unlike humans. In fact, even most primitive life, bacteria, keep learning continually for all their life. And that's, I think, something that will change at some point in the future, but already now with memory, at least to some degree, you can achieve that models keep improving even after being deployed. Okay, yes, go here briefly. I mean, it's not just important to store information, you also need to find the right information at the right time, of course. Lots of integrated things here. Trends for the future, shared memory among agents will become a topic, I think. Private memory, that would mean that important information about you, you only have locally, only you can access, and then LLM, you can allow it to query it, so to get relevant pieces from it, but never to have access to all of it just at once. Okay, very briefly now, world models. What is a world model? A world model is something that stores causal, spatial, and temporal relations. That sounds very abstract. In the end, what it enables is if you observe the world, or whatever, could also be a virtual world, could be the real world, and then maybe consider taking some action in that world, that the model is able to predict what is going to happen next. So it could be a computer game, right? Model only seeing the screenshot, nothing else, and a proposed action, like hitting the down arrow, predicting what is going to happen next. But of course, it could also be in the real world, and a robot, if it, I don't know, raises the arm, what is going to happen next? If a glass of water is about to fall, will it spill? Will the glass split? All of this. You need to know about physics. You need to have common sense. All that current LLMs actually do lack. It's very relevant. You may have heard of Marwick's paradox. What it says is there are some tasks that are very hard for humans, but very easy for AI, like, I don't know, proving theorems in some cases, but also vice versa. A lot of stuff super easy for humans. Every 10-year-old zero shot without training, you can tell it to unload a dishwasher, it will manage. AI does not, even after lots of training. Every 17, 18-year-old with 10, 20 hours of training learns how to drive a car. We train self-driving cars millions of hours, and still they don't even reach human level, right? And that is because they have maybe some kind of word model, but not at a level that humans have or that you would like them to have. And of course, it's super important for embodied AI robots that act in the real world. Yeah, so I think some world models do exist, but they are very rudimentary, and all the big labs are working on that very heavily. So I'm almost done. You may know about this motto from Facebook, move fast and break things. I think it's not their motto anymore. I think a new motto could be for the general public or companies, move fast and don't break things, because that's possible now, I believe. AI agents can build prototypes in hours, not months. That's not just cool because it's faster, but it also enables new ways of working. If completing a given task takes hours for humans, it's super expensive, so you need to plan very carefully what you're even going to try. If it's so cheap, just takes a couple of hours. Instead of planning carefully, you can just try 100 things, throw it at the wall, see what sticks, and yeah, keep whatever works. And I think that's already how startups work these days, and yeah, maybe it's how all of us will be working in the already near future. And the last thing I have, AI coworkers. To close the circle, what is that? A generic AI agent is something that just completes a task. You give it a task, write code, it completes the task, generates the code. An AI coworker would be acting like a human. It reads the roadmap of the company, the sprint plan, the tickets that are there. It self-assigns one of the Jira tickets, writes code, reviews it, creates a pull request. Hopefully, for some time, humans will still review it. It integrates these comments and then creates a new BR. So that's more or less how a developer works already today, right? What does that mean? It means that in this case, AI really has a role. It's not task-specific, it's role-specific. It requires a very deep company context. This is still very tricky today. It needs to have access to all tools in the company, Jira, Slack, GitHub, whatever. It needs to be able to use all these tools like humans do, with clicking and writing, at least as long as humans and AI work together. Maybe in the future, if there are no humans in the loop anymore, this will change. Yeah, I need some memory. Is this the future? Maybe, but it's already the present as well. There are a couple of companies which specialize especially on that. I have some of them listed here. Check them out if you're interested. And yeah, that's all I have for you today. Happy to discuss with you also offline. Oh, sorry about that. But you can find me on LinkedIn easily if you want. Connect, chat with me. Thank you very much.
Thank you so much.